Question 14, and we can see as soon as looking at it that it's a circle theorem question. It says the diagram shows a circle with centre O. AT and BT are tangents to the circle with ATB equaling 74 degrees. So these are tangents coming out from the same point. So if they're coming from the same point, we know that these two lengths are equal. Okay, and this angle is 74. Right. Calculate the size of each of the following angles. So the first angle we need to work out is AOT, this angle in here. Alright, so we already know that we've got an isosceles triangle going across here with these two lines equal. So we know that this angle here is half of 74. So half of 74 is 37. Put that on straight away. We also know that between the tangent and the radius is 90 degrees, it's a right angle. So we know that's a right angle by there. So now we can see a right angle triangle, AOT. So we've got a right angle triangle. So we need to do 180, take away 90, take away 37 degrees. So, oops. It's 53 degrees. Okay, so this angle by here is 53 degrees. Okay, if that angle is 53 degrees, then this angle is also 53 degrees. So I'm going to pop that in as well, because these two triangles are identical. Right, now I've got to find angle OBC, OBC, so this angle here. Okay, if I look at the diagram, I can see that I've got two radii coming out. So these are both the same length. This is another isosceles triangle. So these are the two equal sides, so these two angles are equal. So first of all then 180, take away 53 is 127. Now dividing that by 2, because we've got two of them, 127 divided by 2 gives us 63.5 degrees. So we've got that angle there is 63.5 and that angle there is 63.5. Finally then we've got to work out angle ACB. ACB, so that's this big angle here. Okay, we've almost done that because we know that this is 63.5, so all we need to do is double it. So 63.5 times by 2 is going to be 127 degrees. Okay. Let's have a look at part B now. Oops, I can't open the paper. There we go. Okay, it says the radius of the circle is 8 centimetres. So the radius of this circle is 8 centimetres. So these lines are both 8 centimetres. So is that one there. Calculate the perimeter of the quadrilateral TAOB. Okay, so I need to work out the perimeter, the distance, right the way around this quadrilateral. Okay, I know those two sides are 8. They've given us that with the radius of the triangle. And we now need to work out this length. Okay, if we look carefully, we can see that triangle OAT is a right angle triangle. And I'm going to sort of swizz it round. And hopefully you can see the triangle there. Okay, there it is with the right angle. So I'm going to redraw that now by here. So right angle by there. This is 8 centimetres and this is 37 degrees. And we want to find this side. So we're actually going to do some right angle trigonometry. Okay, so step 1, label up your triangle. Opposite the right angle is H, opposite the angle is O, the one left over is A. Write down SOHCAHTOA. SOHCAHTOA. Cross off the one you know, O, and the one you want, A. Circle the one with 2 crossed off. So we're looking at using tan. Right, tan x equals O over A. So we've got tan 37 equals 8 over question mark. We don't know that. Okay. Because we're trying to find this side on the bottom, we need to cross multiply here. So we're timesing by question mark on both sides and dividing by tan 37 on both sides. And we're going to get that the question mark, the side we want, equals 8 over tan 37. Working that out, we've got tan divided by, 8 over tan 37 equals, and we've got question mark to equal 10.6 centimetres. Okay, so now we know that this part here is 10.6 centimetres and this part is 10.6 centimetres. So now all we've got to do is add it all together. So the perimeter equals 8 add 8 add 10.6 plus 10.6. So what have we got? 16, 26, 36, 37.2 centimetres. Wow, that was one heck of a question.